Yo, welcome! In this video we'll be creating the first part of my slime tool, the edit mode. This mode is meant for the user to place down the lines and get a quick and dirty overview of how the slime geometry eventually will be generated. This is meant to be as quick as possible, and as you can see I can edit the curves and I get updates in real time. Right. So to start, I made two curves and some standard environment geometry. This will be the Unreal environment. So first, on our input curves, we want to resample them. On this resample, we want to put a length of 1 so that we, no matter what our users as input curves give, we will always get a curve that is separated in segments of 1 meter. We want our tangent attribute to be our normal, and we want the curve U attribute. This will be a value of 0 to 1 along each curve. Then we want to wrangle, and in this wrangle we're going to create some attributes with the curve U that we just gathered. But first we want to use this to get the primitive number, each curve that they belong to for each separate curve that our user has drawn. And we can do this with the function point primitives. We will get all the primitives that this point belongs to, and it puts them in an array. We then set the curve ID to the first entry of this array. Then next we want to make a gradient, and we want to base this gradient on our curve U. So what we want to make of our 0 to 1 value with the curve U. So instead of it going from 0 to 1 from start to end, we want the 0 to be in the middle and 1s at each end, so that we can sort of identify what the middle of the curve is. So to do this, we're making a gradient, and this gradient is now the same as the curve U. If we subtract half from it, we go from minus 0.5 to 0.5. If we make this absolute, we go from 0.5 to 0.5 with near 0 in the middle, depends on how many points you have. If we then multiply this by 2, we go from 1 to 1. Then what we want to do for some control is we want to power this. Put this in a function, and we can sort of control how much difference there is between the middle point and the end point, so how low this goes. So we can make it stay 1 everywhere. We can make it almost 1, so barely any difference, or just go completely to 0, or even have these values going quicker near 0, or whatever. So we want to name this attribute curve data because it makes data in our curve. Then for our world geometry, we want to do an attribute delete, and we want to delete basically just everything so that we have only the position, and then I want to add a normal node, and we can call this world. Now before we continue, we actually want to do some checks on our curves first. If we're gonna take a curve from Unreal, we probably want to make sure that we add a convert. This convert node is going to make sure that we are working with a polygon curve here, and the labs boolean curve node, if you haven't installed labs, should just always have it installed. We can use our world to boolean the curve. This is in case when we have our world and we have pillars or other meshes and the user just sort of draws it through this pillar, so the curve goes from here to here. I can quickly change that. So this will then cut up our lines so that we have a line here and a small line here. This will make sure that the slime will take into the fact that there's geometry here and that we cross geometry that we should not be slime in here, but it will also make sure that these become endpoints because we resample after this. So then what we also want to know, because we're doing a boolean, we don't want really small curves, so we're gonna measure. Basically gonna say we want the perimeter / length, and we can keep it as perimeter, and then we just do a simple blast node where we say add blast perimeter. We just do add perimeter is smaller than 0.1, so that if length isn't greater enough, we just delete those. Then this can go into a resample. This will give the curve u, and this will create the data. So next up, we need to create the geometry that goes around the curves. So to do this, we need to loop for each primitive. So we go over each prim, taking each line separate. And when we have separated a line, we want to go over each point. And then for each point, we want to copy to point a circle. So this will now copy circles on each point. But to get a little bit more randomization, we can scatter points on this circle. So instead of having points along the border, we have points in the middle. And here we can just say we want 8 points, and then we have 8 points around each point. In these scatter nodes, we can add a spare input, and we can add our for each begin to the spare input. And then in our global seed, we can say point of -1, point number 0, attribute p, index 0. So this will give us the x coordinate of this point that we're copying to. And this will randomize the order that's in here. So if we also add the y coordinates and the z coordinates, we now have a random seed for each point. So for every point that we copy to, we will get a different layout of the points that are in here. And we can call this loop curve points. So curve points begin, curve points end. We can call this S line at a wrangle. And we can create an ID attribute based on the point number. So e at ID is speeding them. This will solidify their point number into an attribute. And when the curve is done, we have multiple points with the same ID. Create ID. After we have our ID, we can simply add an add node. Go to polygons, by group, select by attribute, and say ID. And now we have connected each line based on the ID they had in the circle. So let's go back to our curve data and just do one last thing. So we want to manipulate our p-scale based on our gradient. And we basically want to multiply our gradient by a certain strength. And we want to add a bias so that we can have a minimal p-scale. This p-scale will control the size of the circle or the size of the groups of scattered points. And so it will determine the width. And because we have the strength of our gradient and the power of our gradient, we can control how much this sort of snares in. And we probably want to keep our bias somewhere above 0. So for example, you did see that these gradients go to 0 because there are only 3 points. These have an uneven number of points. So we don't want to make sure that they come to 1 point, sure. But it's best to just keep it at 0.3, and we can set the strength to maybe 2. We can start by converting our network to an HCA. So we will select everything, press Shift-C for collapse, and this will make a subnet. And we just want to make sure that the curve is our first input and the second input is the world, and just flip this around. So now I can right mouse, create digital asset. Probably want to name it slime tool. You can add your own menu. This will be the menu that it appears in when you press tab. I mostly don't want a type category that will put subs in front of your file name because it's a subs node. But save it in a place that you want. I just want to do it in my hip, and then just press create. Then our minimum should be 1 because we want the curve. We don't really need a world if the user doesn't want to. And we just want to make the tool work without showing an error if there's no world input yet. We want to go to input output. We want to set this to curve. so that Unreal can recognize that this input is a curve input and that this is a world input, and this will automatically tell Unreal that this HGA can have outliner input from an Unreal scene and that the curve should be a curve in Unreal. Then for the parameters, we most likely want a width, and we want the amount of lines. We can just hit apply and accept for now. We can copy the lines, put a number in, and the lines will go in our scatter. The width will be in our curve data. I don't really want my users to touch any of this, and I want to keep it as simple as possible, so I just give them the scale to play with as a width. Now I can just scale up and down. I might expose the power later on, but it's fine for now. Then we have our out node. We can drag that down. Right. Now I want to work with our roll input, because we want to make sure that our lines are grounded against these geometries or these faces. As you can see, they might intersect and they don't really look like they originated from the geometry or that they're hanging on to it. Grab an object merge and drag our world in the object to get it down here. We want to add a group node, run over points. We basically want all the points that have a gradient that is higher than 0.9, so that we have all the 1 points, and if we have a really long curve, we also take the second curve of second points. And then we want to add a wrangle node that takes our world as second input and our curves as the first. And we want to call it to first. And in this wrangle, get a distance from the point position to the first input. This is the 0th input. Then we want to say if this distance is greater than our max distance, which we now put at 0.5. Then we want to say we create a point, we save the point number in this integer, because then we can set the point group of this new point to ends. Sorry, we need to name this group ends, because these are our end points. I don't know if you can see it, but our ends are selected here. And we want to add these new points to these endpoints. So we're basically saying for all these points, check the distance between each point and the surface. And if it's below 0.5, we want to say, well, create a new point on the position and set that point as an end group. We want to create some more attributes. So we do set point attribute, and we want to set the gradient to the same gradient as set point is, and same as the curve U and the curve ID, so that all these attributes are passed on from our parent point to our new point. What we now can do is we can get an array and you can say, well, get a minimum distance and just ray our ends to this surface. So now all our ends are somewhere on the surface. But we actually want more points on the surface, just to make it look like they are really attached to it. So to do that, we add a blast, and we're going to take the output of our wrangle with all the endpoints. And we want to say, let's blast the ends, but then only keep the ends. Then we want to take a sphere or any geometry, and an add node to just delete geometry but keep the points. Then copy 2 points, make it polygon, reduce it. And now we have a bunch of points scattered on our endpoints. Because they are copied to it, they will automatically get all the attributes that our endpoints had, so also the group. We can add a point jitter, can just stay at 1, doesn't really matter. We just want a bunch of points based on the locations where our points were, and we also ray those to the surface. And for that we need to merge. And now if I disable this because it's getting colored, you see that we sort of have all these points now on the locations where our slime is close to the surface. And we can, because we're adding new points, we're not really affecting the points that are already there. So this first group is taking care of the ends of our curves, which are getting rayed to the surface, so they are moved. But for all other points, because these are now also detected by this, but only their copycat with points scattered onto them is getting rayed to the surface. So we're not really getting a displacement of our complete slime line. We're just getting the ends snapped to it, and then we have additional points that we can now build upon. So next we want to group expand. We want to expand ends and name it ends. We expand this group and we name it just the same. So we now only have these endpoints, and these are connected, so it's only affecting these, not all the loose points. And because we're stepping, there's now one extra point from the end that is in this group. We then need to do a convert line, and we will blast the ends here, and we don't blast the ends here. So because we're blasting the endpoints here, because we want to connect all the points that are not our curves, because these are already connected, that's fine, but we just want to connect all the new points that we created. But because we're blasting the endpoints, you can see that the curve actually gets deleted to the second point. So we're losing this part of the curve. And if we don't expand our group, then you see that this actually only keeps the end point, but because we don't have that second point, this section of the line is gone. And if we expand it, we take this into consideration, and we have this part in this group and this part in this group. So now to connect them all, we're just going to use connect adjacent pieces. This can run over adjacent points. And we want to put the search radius to 1, something big, and we want to limit the max search point to 6. And we don't really need that much of connections anyway. We just want the basic points to be connected. We can then merge this back with our regular lines. And now we already have some pretty nice looking structure. We can limit our to surface a little bit to not have everywhere. So for the next part, we want to make more connections between our baselines and the lines on the surface. And to do that, we're first going to use a wrangle to delete points that we don't want to go over, because we don't need to go over all the points, we just need a couple of them. And we're just going to say, let's take half for now. So now that we have half of our points, we want to group this, and we name this group old. Set it to points. This is so that we will know after making new lines what our old lines were, so that we can delete them and only use the new ones. Now I want to make a pretty big wrangle that we're going to name connect, and this is going to connect some of these lines together. But we want to connect them with, not with the lines that are closest to them, but with lines that are the furthest away, presumably, or somewhere near that. So we can't use connect adjacent pieces, because this will connect based on proximity. So we need to make our own little logic for that. So first we want to get points, and we're going to use PCFind to search in the same geometry for our position around our current position. And as radius, we just want infinite, and then we're gonna say search points as integer. So this will give us a list of points, and this will be the same as the connect adjacent pieces. So what we want to do is we want to take this array and we want to reverse it. So now the last item in the array, which is also the farthest item, is now at the start. And then we can simply slice this array, this reversed array, from 0 to an integer called max points. And we probably want to keep the max points at 1, because we just want one connection. We don't really want multiple. It also keeps it a little bit more performance. So what we have now is that this search points is gonna influence how far away the last point will be, because we only search for 1 point, then simply the next point will be. But if you only search for 3 points, the furthest point will probably be somewhere here. But if we search for 300th point, will probably be somewhere further. We can see our array to sort of visualize the point. So here we have our points. If we don't do this, you see that 0 will have 0 and 1 will have 1. They all have themselves in their array because they are the closest point to their own position. And then we have 111, 112 at the end. And if we reverse this, we only get 111 and 112. If we decrease this, you see we only get the first one. I would like to give the user a set distance, and we will multiply the distance by 100 to sort of have control where the user can still sort of dial it in, because this is too hard a problem to fix if we can just give the user a parameter. So like, what do you want, more distance in the connections, or do you want them to be closer to the points? So what we want to do next is we want to go in a for each loop, and you basically just want to go for every point in points we want to loop. I'm going to say if our ptnum is the same as pt, which is not really possible, but we just want to add it in. And we want to say if our point is less than our ptnum, we're also going to continue, because we don't want to make the same connection twice. So if this point finds its furthest point to be this point and the other one does the same, then we'll get two lines crossing each other. And we can just say, well, if your point number is less, then you're not making the line and the other point will make the line. So this sort of also cuts our processes in half, but make sure that that doesn't happen. So next we take the random of our point number, evaluate it against a chance, and if we are lower than the chance, then we can add a primitive. Then we add a vertex to the primitive, which is the point we're looping over from the found array, and we will add the current point number that we were searching from, so that we get a line between the two. Then we want to set some attributes. Remember this old group, we want to tell that this new point is not an old point. And we also want to set the old group of our current point to 0, because we don't want to delete that one, because we're then also going to delete the line. Right. So that is the code for this. We still have to get our chance value. So we're at 0.5. Now you see that our distance value is way too high. This is about right. So let's go into our type properties and make some floats. So we want to have toSurface distance and toSurface chance. Make this from 0 to 1. Right, and now we can control the distance. If we now blast the old group, then we can see what our new lines are, and we can merge them back into the main chain. So now we see that we have these connections that are sort of latching onto the falling or hanging lines. Okay, so we want to fuse our points together so that we can subdivide them, and this will split it out a little bit. Then we can use a resample. Just take a setting that you like. I think interpolating curves is nice. And then we take a pretty small length. And then after we resample, we're actually going to do an add, and we're going to use the delete geometry but keep the points, so that we completely break our structure. So don't click on that group. So now we only have points again, and we're like, why would we do this? Well, now we can again fuse them, and we want to fuse them with the same distance that we have here. Sort of get rid of all the points we don't really need. Least point number, and this will either snap them to the left or to the right. And then we can use the connect adjacent pieces again, properly connect all of them. And we're going to use this length times 2. And then again, we're going to limit this to 6. And now as a bonus, we get these small sort of interconnecting lines if they are too close. So they will sort of become this. Yeah, you see this a lot with stringy fluids, that if they come together, they sort of merge into one sheet. And now we get this because these are then too close and the connect-adjacent pieces connect them. And what we also have now is a structure that is usable for simulations because every point is now, or every line is connected to all the others, or at least 6 others, so it will sort of be a coherent simulations piece. We do have some lines that are disconnected, but that doesn't really matter because it will actually add some quality to it. Either this point is going to be pinned because it is an endpoint, or it will add sort of a hanging stringy thing that kind of looks nice. And the last thing that we want to do with this is put it in a compile block, because this will be the edit mode of our tool, and that means that the user will place the curves in this mode and start moving around. So we want this structure to be generated as quick as possible so that the user has a great experience editing the tool. It doesn't have to wait a minute. It will just be within 1 second and it will be there. So with a compile block, we have to make sure that everything is linked with pair inputs. So we can take our curve input, move all of this down, put a compile block on it, and put the end. We can see what errors we get. So the attribute delete node doesn't really work, I believe. Like the thing I found, where is it? Is it in here? This is deleting attributes that we're not using anyway. We can allow editing of contents and the error will go away. I'll probably need to do the same here. So if we now edit our curves, everything still works. So this is quick and it works. Only thing is, if we're going to export this to Unreal, Unreal is going to complain because these are only lines. So we need to convert them to geometry. This will be at the end of our tool somewhere because we have multiple modes. So we're gonna use an object merge to get the output of this compile block. So where we have our edit part, we want to add an orient along curve, just so that the curve has the normal in the same direction, and this will make the sweep act better. And in the sweep node, we want to set it to round tube. Probably only want 3 columns. We don't really need it to stretch around curves. We don't want to apply roll or twist. And in construction, we also basically want to turn everything off so that it doesn't do any extra work to calculate this geometry. And while the user is editing this mode, we want to give the user a little bit of feedback on how long this will take if we were to, say, convert this into the complete slime geometry, which will be using VDB systems and stuff like that that takes a long time to compute. So we can put this into a box and check oriented bounding box, and this will give the bounding box around the volume of the curve. And you see that we still have a lot of empty space. So actually, if we use our for each point, but then again use a piece attribute, and we use our curve ID, the ID that we use to identify which curve the points belong to. And this will come in handy now because we can loop over each curve and then we can box that. And now we have a box that more so aligns to the geometry. And if we do that for all of them and merge them, we get this. Now, if we now measure this, we have a lot better representation of our volume than compared to this, because this has way too much empty space. This is a lot better. So if we then say we want to measure the volume and we want it throughout, this will basically measure each part as separate and then add all those together. If we then attribute transfer that back on our geo, and we say we want to transfer the volume, and then we can color it based on primitive ramp from attribute, and we say volume. Let's use infrared and go from green to red. Now if we increase this one value, you can see that it becomes greener. So now the user knows, all right, if my geometry is green, then I'm probably good to go because it doesn't have that big enough volume that it will crash my PC. And you have to manually set this to something that is around your team's hardware requirements or the average spec. And after this, all we want is a group delete to just delete all the groups, and an attribute delete to just delete all the attributes except our color, because we want to keep that color. And then this will be our edit geometry, and this will then go into a switch node in which we switch the mode. So we'll have one mode that is for editing the curves. We have one mode that is for editing the simulation, and then we have a final mode which will output the final geometry. And then our output goes here. And this is the end of the first part. In the second part, we will tackle the simulation and we'll look at how to mesh this stuff.